Let's solve this problem using Java, the same approach that we used in the previous video. I have included one extra terminal index as 8, which will be always having 1, because once we try to calculate the base case, the last index, it will check for the remaining next element whether it's greater than or not, and then it will be choosing 1. So that's why I have included this extra terminal character as null character as 1. Now let's head into IntelliJ and solve this problem. Check this method. And I will pass the same. Using the same example as given here in lead code. Okay. Now we have solved this problem. We had this form. Again, to reiterate the formula, we are going to start from the last index element as 1. And then we will keep on moving to the previous indices until we reach the 0th index. And for each of the LIS at that particular index, the formula is that it should be the max of 1. If we just choose it at 1, and if it's less, and we can only include the next element if the current element is less than the next element. And suppose we are at this index, then it would be keep on calculating for all, comparing all this with the next index element which is less than that, and include that in this formula. So first of all, let me declare this array where we are going to mark it as TP again. And I will take nums.length. Or maybe I just take this value. And just take length. Mark it as 5. Okay. Now by default, the DP is always defaulted to 0. Now this length, we have calculated that this is as 8, right? So from 7 to 0, it's 8. The length is total 8, and we include this extra terminal condition. So it should be 1. And I will mark this DP of maybe just fill all of them as 1. Fill DP as 1, because by default it's 0, so I just mark it as 1. Now we need to iterate from this 7. Nums.length is equal to 8, and then we need to use from 7, and we need to move to 0 and keep on calculating using the bottom-up approach, starting from the last index as we have seen here. So I will use for I loop, and I would be len minus 1. Len minus is 7. We start from here. And I is greater than or equal to 0. We need to go to the last, first index. And then again, another for loop. We start with, okay. Now for each, the next loop, it would be, if I'm starting from say 5, if I is equal to 5, in that case, we need to compare all the remaining until we reach to the terminal, to the end. So it would be I plus 1. Okay. Yeah. And then we use this condition. So we start with I, and then keep on comparing for each of the next elements. If the current element is less than the jth element, then only we'll use this formula 1 plus lis at this number to calculate, and then we find the maximum for all of the remaining elements. So if nums of I, which is the current element, is less than nums of j, which is the remaining the next elements to the current element, only then we are going to store this value as like this. Otherwise, it would be always 1. That's our minimum value for that. And otherwise, it would be 1 plus dp of j. Yes. So this is all the formula about. See, such a simple formula. We just use 2 for loops and using the same conditions here. This one is less than, we include it, otherwise not include it. Only if this condition works, then we are going to calculate the dp value at that index. And now we have got this loop here. Now we need to return the maximum of it. So there are 2 ways we can do it. We just can use a for loop. For example, if I say int result is equal to say dp of 0, right? And then we do a for loop. All right, if for int I is equal to less than length, so start from 1. If the result is less than dp of I, then result is equal to dp of I. It's just a very simple formula to calculate the maximum number out of an array, and then I return the result. Yes, there was a small bug here. I just used dp1 before, so it should be dpi, right? So yeah, once we have this, now we find once we have this dp final array using these conditions, and we just take the maximum value out of it, and let's run this. So we got the answer as 4. Now, yeah, let's, for all the different scenarios, because we have just covered one test case here, let's use the LeetCode platform to find for all the possible cases. Let me put it here. Let me then try the solution on LeetCode, because it will cover all the different scenarios, test cases possible. Yeah, so solution is working here. I mean, in Java, we can also find the max by using stream. So instead of this, using this for loop here, I can just convert this into a stream. dp, then find the max. Now max will return me an optional int, and I can just mark it as get as int. So this will give me the same result. This is like just another way how to use Java Stream Powerful API to do the same thing. And answer is 4. So again, let me just copy this and again try it in the LeetCode. Submit it. It's taken 90 milliseconds. So we found that, and there is a small difference when I use the Arrays.stream, it is taking 90 milliseconds, and if I just use a simple for loop, it's taking 76 milliseconds. But nevertheless, I mean, we're not talking about optimization here, but we are just thinking about how to solve this problem using dynamic programming approach. Now let's look for the time and space complexity here. So here we can see that we are using 2 for loops here, starting from one index to the last index, and then for each of the element we are doing the comparison for all the next element here. So I think the time complexity would be then O of n into n, where n is the length of this array, and the space complexity would be only O of n, because we are only storing one DP array of one single dimensional array. So this is the time complexity n squared and the space complexity as O(n). So that's it, friend. That's it about this longest increasing subsequence problem. In the next video, we will solve the third problem in this tutorial series, which is shortest common supersequence. This is considered as hard problem, but we'll see that how we can approach it, take on this problem, and solve it into the most intuitive way possible. So that's very evident how to approach this algorithm. Thank you.